So let's go ahead and put our formulas to use here. We want to compare some standardized math competency scores for traditional teaching method versus a group teaching, so 2 sample tests for 6th grade students. Random samples were taken from each population, and then here's the data. So we want to construct a 99% confidence interval for the difference in means and interpret the result. So requirements, independent random samples here. We do have random samples from the 2 populations, so that's all set. Both populations approximately normal. There's standardized exams, and standardized exams have approximately normal population distributions. So that one's okay. And then the 2 variances need to be the same, a constant. This we would have to assume. It makes sense that they would be the same, that there would be about the same amount of variation between group teaching and normal teaching. Actually, it's possible it could be a little bit less, but that we'll have to assume. Our alpha, 1 minus 0.99 is 0.01. Our degrees of freedom here. So N1 plus N2, 15 plus 17. And then minus 2 is 30. And then alpha over 2 is 0.005. So our T alpha over 2 is T 0.005. We're going to use inverse T to get that one. Our left area will be 0.995. And our degrees of freedom, 30. And if you enter that in the calculator, you will get 2.75 to 2 decimal places. So now we compute our pooled estimator, N1 minus 1, so 15 minus 1, 14, times our S1 squared, so 2 squared, plus 17 minus 1, 16, times S2 squared, 2.9 squared. And then we're dividing by our degrees of freedom, 30. And if you put this in the calculator, you'll get 6.352. And now we're ready to go ahead and plug in the intervals. So the difference of the 2 means 6.5 and 7.1. So 6.5 minus 7.1 plus or minus our t value of 2.75, and then times our standard deviation, which is going to be the SP squared, 6.352, and then the sum of the reciprocals of sample sizes. So 1/15 plus 1/17. And you plug this into the calculator and you'll get 2.46, and then this difference is negative 0.6. So negative 0.6 plus or minus 2.46. And that gives negative 3.06 to 1.86 if you do the calculator work there. So notice here that this interval contains 0. So we can't make a decision. It's not a statistically significant difference to say that mean 1 minus mean 2 here is greater than 0 or less than 0. And the interpretation here is we are 90% confident that the true mean difference, mean 1 minus mean 2, is between the negative 3.06 and the 1.86. So that means if we took 100 pairs of samples and computed the confidence intervals, that 90 of those intervals would contain the true population mean. And then we can verify what we're doing on the calculator here using the stat functions. So let's do that real quick. So clear out. So we're going to go to stat and then tests. And then we want a 2 sample t interval, which is choice 0. And then make sure that stats is entered. And then we input our x1 bar was 6.5, s1 was 2, first sample size 15, second sample mean 7.1, second standard deviation 2.9, second sample size, and then our confidence level 0.99. You want to make sure that yes is highlighted on the pooled estimator and hit calculate. And there is our negative 3.06 to 1.86. And listing all of our listing all of our sample evidence here. And then here's the pooled standard deviation, 2.52. If you square that, you get the 6.352.